So coming to the next lesson, that is property of orthogonal matrix. So multiplication by any Q preserves length. Why? Because the Q matrix is orthonormal, and when you are multiplying it with its transpose, you are getting it as length is equals to 1, because we call it as an ortho. All the columns of an orthogonal matrix are orthonormal. Hence, the multiplication by any Q preserves its length, because you are multiplying the length with 1, so the length is preserved. So let us check this. It will prove that. So length unchanged means if I am multiplying the matrix Q with x, then the length of x should remain as it is. So that is, we know that the Qx is nothing but a inner product, so, and you can also call it as, it also preserves your inner products and the angles. Even the inner products and the angles, that is multiplication and the angles, it's because Q can be a rotation matrix. So all that are preserved, not only the length. So here you can check it with, I'll take this one, Q transpose, to prove that I'll take Qx transpose with Qy, and that is how do you find the length, right? So here I'm taking two vectors, x and y. So I'm multiplying Qx with transpose, I'm taking a transpose, and Q with y, and there are two vectors. So here what will be the, if I expand that, what I'll get? X transpose and Q transpose, because while transpose I have to change the position, and next is Q into Y. So here you can see Q transpose Q. What is that Q transpose Q? This gives you an identity matrix I. So Q transpose into I into Y gives you what? X transpose Y. And so you can see that you have, when you are multiplying with X with Q and Y with Q, what you are needing with me, they are remaining as it is, X transpose Y. So here itself we will come to know that if you are multiplying it with a Q, your equations or the length remain as it is. But still you can check it with under, that is if I take Y being the same, that is Y is equal to X, when Y is equal to X, if Y is equal to X, what I can have, that is Q x square equals to x square. If I want to prove that, I'll take this equation. So if I take y equals to x, I can write like this. So y is what? X transpose. And what does this gives you? This gives you equals to your original length of the x. If they are orthonormal, it will be 1. And if it is other than orthonormal, because only orthonormal vectors will have the total length is equal to 1. So it will be equal to the length are remained same. So automatically the length will be equal to 1 when we are having a orthonormal vector. So here next is making use of that fact. When you are multiplying x with the q orthogonal matrix, the length of the vector remains same. We'll try to find the coefficient of the basis vector. We'll try generate the coefficients of the basis vector. So here let take the basic, let b be written as, I can write b as in terms of q and x, because I will be writing, that is usually you have an habit of writing ax equals to b. Now I can have it as qx when I am multiplying x with q, qx equals to, because that remains, the lengths are remain same, I can call it as qx equals to b. So I have b here, so I'll have x1 q1, because the matrix first column I'll have at a q1, and second vector q2, and n vector qn. So you are having n columns, n vectors. So x1 q1 plus x2 q2 plus so on till xn qn. So let us multiply qn transpose on both sides, so to find out the coefficients of x1. So similarly, you can find out the coefficient of x2 by multiplying this equation 1 by using q2 transpose. Well, let us see what happens when I am multiplying it with a q1 transpose. What happens? So the left hand side I am written q1 transpose b. Right hand side here, when I am multiplying with q1, x1 into q1 and q1 transpose, q1 and q1 transpose will be left as it is, and you have x1. So the other vectors, when you are having a q1 transpose with q2, that is equals to 0. Why? Because if I is not equals to j, And if you are taking a transpose, if they are orthonormal vectors, and so it just gives you what that gives you a 0. So using that property, you have only this one. And what will be if they are orthonormal? What will be the value of Q1 transpose and Q1? This will be equals to 1. So what will be the coefficient of Q1 transpose B equals to x1 I'll be getting. So what will be the coefficient? Coefficient, I can take the coefficient of B, or that is Q1, I'll have x1 equals to Q1 transpose B. Similarly, I can find out for the coefficient of x2, that is Qx2, sorry, coefficient of Q2 as x2. So for that, what I have to do? I have to multiply this whole matrix with the Q2 transpose, so that only this term is left out and all other terms become 0. Similarly, for Qn, I can multiply with the Qn transpose and with on both sides, so that only this term remains and all other becomes 0. So likewise, you can find out all the coefficients. So you have every b is equals to what now? So every b, that is b1, b2, b3, all the values will be equals to what? It is nothing but a single vector, that is q1 transpose, q1, q2 transpose, q2. So in this itself, that is the coefficients of b will be, that is b1 will be this one value, b2 will be this value, bn will be this value. So you can see here q1 transpose b, because this is q1. If I am multiplying q1 transpose to b, what I should get? I should get q1 transpose b. So that is x equals to q1 transpose b. So everywhere I have got x1 when it is q1 and x2 when it is q2. So I have written the same thing, q1 transpose into b. This is the first vector coefficient. So second vector coefficient you will have it as q2 transpose b. So likewise, I will be generating the values of x using a cube. So it is same as solving x equals to b, as I already told you. X is equal to a inverse b, or that is because we are solving it when the columns are not orthonormal. In that case, we need a inverse, because but when they are orthonormal, you can make use of q transpose q, because q inverse is equals to q transpose. But if they are not orthonormal, then you have to find out, x, you have to have a transpose, that is a inverse into b. Okay. So next is, so what you have I told you about the remark one already. So this remark I had done, that is every vector B is the sum of its one dimension projection onto the lines through the cubes. So you have A transpose B, A transpose A divided by A transpose A. This is for what? This is for your single dimensional vector. You know that. So you can treat every vector to be a single dimension. That is for B1 you can treat a Q1 as a single dimensional vector, and for B2 you can treat Q2 as a single dimensional vector projected onto the cubes. So here that is for one of the remarks. So I can say B square, that is the length of the B will be what? Q1 transpose B square, that is each values of B will be squared, and you can say it as Q transpose B square. So I told you by the multiplying with B, the length remains same. So here also Q transpose, you know the property of Q transpose with the Q, that is the Q inverse. So you have in this meaning, that is Q inverse multiplied with Q. Here I am Q inverse into B, and that is Q transpose and Q is equal to Q inverse. So it is nothing but QB into equals to B, or either in the terms of transpose, both are equal. So that is one remark. And because of this only I am able to write this second remark also. Q transpose equals to Q inverse, and Q transpose equals to Q, this you know, and so you have this remark. So using that only I will be getting this, right? So this is about the getting coefficient. So next part